Got to turn on my video, so I missed this. I'm so sorry. I just looked. My clothes rack is in the way. So sorry. So none of these functions is a pure function, pure exponential or pure cosine. No, because this is not pure t or pure x. It's negative 2t. And this argument, again, is not just plain t. So there is a function inside e to the x, and there is another function inside cosine. So, y prime, or better dy over dt, is, this time I will have to have a sum because it's the product rule. So once it's the product rule, this will be a product and this will be a product, but I have to have a sum. If I only have a power, like we had a minute ago on this, allow me to go back for 1 second. If I only have a power, so function raised to a power, I'm going to write the formula again. I get 4 times the function to the third power times the function prime. But here I have to have a sum because it's a product of two functions. So the first function prime, e to negative 2t, is e to negative 2t times the inner function prime, which is negative 2, times the second function, cosine 4t, plus. I copy the first function and multiply by the second function prime, which is negative sine 4t, but times the inner function, which is prime, which is 4. So now I have to rearrange the whole thing. I can factor out, if you want, the negative. Let me rewrite it before so you can see it first, simplified. So this is negative 2, e to negative 2t times cosine 4t and minus 4, e to negative 2t sine 4t. We can factor if we wanted to. It's not really important because we're not going to do anything with this, but let's do that. Negative 2e to negative 2t, and we do have cosine 4t and plus 2 sine 4t. So two things. Yes, go ahead, please.
Lined up where you first wrote negative sine 4t, is that a times 4 at the
yes.
end? Or what is that?
Yes, of course. Yes, sorry about that.
No problem.
You already know now that I always run out of room. So, two things I would like to mention here. Here's one. A function raised to a power prime, which we already did on the other page, is n times f to n minus 1 times the inner function prime. And also, we know that e to the x prime is e to the x. But if we have e raised to a function prime, we have e raised to that function multiplied by the function prime. The same thing with anything like cosine sine of a function. So I can have cosine of a function prime. So then I have negative sine of that function times the inner function prime. We did this in the past without telling you, right? If you remember, I said times x prime, but there is no need because it's 1. We basically always use this, but we don't write this if it's 1. Okay, any questions so far? Any questions? Now we can finally differentiate something like f of x, let's say, equals 1 over 1 plus secant x squared. So do you think I'm going to use the quotient rule? Well, you know I'm not going to, because I like simple things. I don't like to worry about something like this, a quotient rule, when when the numerator is just 1. There is no need for that. You can, but 1 prime will be 0, so, and take it from there. So f prime is, it's a function to a power. I bring down the power, I subtract 1 from the power, and now I have to differentiate the inner function. 1 prime is 0 plus secant prime is secant tangent. Yes, I will rewrite it. Any questions? Any questions? No. Okay, I would like to look at something with the square root now. Let's say the square root of 1 plus x e to negative 2x. I have to refresh my memory on the fact that the square root of x prime is 1 over 2 the square root of x, and what I should have written, and I didn't, is this, times the inner function prime, but there was no need, because it's 1. But now, if I have the square root of anything else but x, any function but x prime, I do have 1 over 2 the square root of the function times the function prime. So this is the inside. This will be prime here. The rest is 1 over 2, that same thing, square root of the function, all this piece. But here I have to differentiate the inner. And notice that the inner is a product. This prime will be 0. Okay, so let's see what happens next. So, this is 9.6. So we have dy over dx equals 1 over 2 the square root of 1 plus x e to negative 2x. And now I open parentheses, and I know I'm going to have a sum. Because 1 prime is 0, but this is a product. So the first function times the second function. The first function prime is 1 times e to negative 2x plus the first function, but multiplied by e to negative 2x, but times the inner function prime in parentheses negative 2. So, did I write this here? Yes, I did. I did write it. Okay. So, what I'm going to do is just factor out e to negative 2x, e to negative 2x, and let's see what is left in parentheses. The denominator is still the same thing. And then we have 1 minus 2x. And this is final. Any questions for me, please?
Yes. What did you write above the final answer where it says e to the negative 2?
This one?
What is that beside?
This one?
Yeah. What is that?
It's my page number, I'm sorry.
No, not your page number under that. Is that negative 3 times negative 3 or negative 2?
It's the inner function prime. Negative 2x prime is negative 2.
Okay.
It's right here also. Negative 2 times x. Is that better?
Yes, it was just like you ran out of room a little bit.
I always do. Are you surprised? I'm not surprised. Now, here's a problem that I would like to work on step by step. because we're going to see this in later chapters. Sorry. It's g of y. Okay. Of course, we want to determine g prime. Watch me run over room this time. I'll go ahead, just write a denominator quickly, because it has to be squared. So now I have to differentiate the numerator. I bring down 4. I multiply by y minus 1 to the third power. And I should multiply by the inner function prime. Lucky me, the inner function prime is 1. But now I have to multiply the denominator by the denominator, which is this. So one more time, what does this represent? This prime times the denominator. Now I have to write minus. I copy the top, and I have to differentiate the denominator. Careful now. I bring 5 in front. I write y squared plus 2y to the fourth power, of course, and you already know that. I'm going to run out of room. Right in here, this spot should have 2y plus 2. This is a very important type of problem. Why? Because we must factor to simplify. Must factor in order to simplify. If you don't factor in order to simplify, you're never going to be able to factor. It's not going to work.
Is that because, so anytime we do the quotient rule, will that be?
No. Look at these powers.
Okay, okay. I was just.
If I start distributing now, I might be able to finish by Wednesday. If I don't sleep tonight. So you must factor in order to simplify. And I notice that I don't know how to put this in here because I have all my cords and stuff and my other devices, and I don't know. Anyway, so I'm just going to do this, cover this. Okay. So I'm going to continue here. I see that x minus 1 is common to both terms. This is one term, and this is another term. So I see that y minus 1 to the third power will be common because the smallest power is 3. I also see that y squared plus 2y power 5 power 4, I will factor out power 4. Then I will open brackets. Of course, I'm not going to have enough room, so you know that. So I'm going to erase this and put it here and leave some room because I may have to write. And the denominator stays as is for now. So let's see what is left. Okay, so 4 is still left in there. Y minus 1 cubed is out. From 5 I took out 4 of those, so I still have y squared plus 2y. Now I reached the symbol, which is minus. I have to copy the 5 and multiply by. This is completely out, so I need to multiply by 2y plus 2. So, of course, y minus 1. Okay, so 5 is out. 5 is still in. From 4 I took out 3, so I have 1 left. These 4 are all out, but I still have a 2y plus 2 left in here. at this point, and only at this point, I'm allowed to simplify. So 4 of those are out. Let's see what is left. Y minus 1 to the third. I will distribute the 4y squared plus 8y. Here I will have negative 5, let's leave it alone. I will distribute y to these two terms, 2y squared plus 2y, and negative 1 to these two terms, negative 2y minus 2. Y squared plus 2y to the 6th power. I see that these two go away. Now I have to distribute 5 to these two terms. So I have y minus 1 to the third, and then 4y squared plus 8y minus 10y squared plus 10, and everything divided by y squared plus 2y to the 6th, which, to be exact, I can simplify, but we can leave it as is. I'm not going to change it, but you could take out a y, so it will be y to the 6th and y plus 2 to the 6th, but you don't have to. We will not be able to simplify anyway. It doesn't appear that we can. Okay, so let's see the final answer. I have negative 10, so it's y minus 1 to the third. I do have a negative 6y squared. I do have a positive 8y and a positive 10. Y squared plus 2y to the 6th. And yes, I will factor out negative 2 from, I don't like a negative leading coefficient. So negative 2, y minus 1 to the third. And then, of course, I will run out of room. So this is 3y squared minus 4y. I'm going to write it again. And minus 5. Don't even write it. I'm going to copy it again on the next page. Okay, so then the final answer would be negative 2 outside, y minus 1 to the third, 3y squared minus 4y minus 5, and everything divided by y squared plus 2y to the 6th power. And this is final. You understand that there is no other way of simplifying this but by factoring. Impossible. Absolutely impossible to simplify this unless we factor. Any questions on this problem? Any questions?
Would we have to simplify this far on like a test? Because I know on WebAssign, I don't think it makes you simplify that much.
These are mandatory, absolutely mandatory.
Okay.
It would not ask you to simplify this far if it's way more complicated than this, with rational, with fraction, with radicals inside fractions and stuff like that. But yes, this is absolutely mandatory. That's why I did that all the way.
Okay.
Yeah, absolutely mandatory. Okay, let's just play with one slightly more complicated and then move on. Something, let me see with the time, so let me stop this and let me start